welcome friends once again to the NPTEL module on handling healthcare survey data. We are on the verge of third week where we have been trying to understand how to normalize healthcare data. Especially we wanted to address the specific practical sessions within the lectures where you guys will be quite handy in understanding or manipulating data as per the use. So, myself Dr. Pratap Mohanty, I am attached with Department of Humanities and Social Sciences, IIT Roorkee. This I have been handling quite couple of years. So, I can deal with all your doubts related to normalizing data. So, without further discussion, let us start with the meaning of it. Regarding normalization in data mining, the first one we wanted to highlight that this contains with certain attributes such as different units, range, scales. What does this mean? Like we are often deal with various data set in our day to day life, where each of the variable is coming with its different units. Their range is defined differently. Also the scales are different. I have already clarified what do you mean by range and scales and measurement in my previous lectures. Now, applying algorithm to such drastically ranging data may not deliver accurate results. That is why normalization in data is the must before going for a detailed analysis. So, in the very introduction, we wanted to mention here that we will be discussing about normalization of variable, its maximum minimum values of the features that are most often used, like is changing the range of the data, rescaling the values into a range of 0 and 1. It is really affected by outliers or not. Okay, this is related to normalizing of the variable. Then second aspect within the normalization is called standardization. Standardization, where we wanted to use or we should use the mean and standard deviation, and like changing the shape of the distribution of the data, and accordingly which mean or median value is used should be a call in our approach. Data is rescaled to have a mean value if it is you are estimating for a large segment of the population. So, mu value is referred of 0 and standard deviation. Data is rescaled to have a mean 0 and a standard deviation of 1. Usually in that format we standardize the data. Likewise, you might have earlier dealt with normal distribution kind of data. This gives values that are both positive and negative centered around 0. So, it is basically standardizing. Standard normal distribution you might have read. Here we on the very first chart we have actual data. Then on the other chart we have just shown you how we see the normalizing data. On the normalizing data and standardize, after standardization what the data actually looks like. So, on the actual data they seem to be very scattered, but after normalization it is having within a caveat, and it is within the range. And also in standardization, as we have seen that it should be again within a range from minus value to plus value as per the standardization we have made. When to standardize or normalize the data, especially in standardization, it is used when we want to ensure 0 mean and its unit with standard deviation or 1 unit standard deviation. It is useful when the feature distribution is normal or Gaussian. Okay, so the Gaussian distribution is usually referred in the context of normal distribution distributive data. Then on the case of normalization, it is used when features are different, with different scales. It is useful especially for normalization when we do not know about the distribution. So, when the distribution is skewed, is not well within the range. So, in that case normalization really helps. Here are some of the chart that is guiding you how your data actually looks like. Okay, so you can compare the distribution. So, here in the distribution you have like on the first block we are discussing about standardization. On the second standardization you can just see how it looks. So, on the first one it seems the data is more or less confined near near 0. But after basically 0, even if it is a normally distributed data on the first scale, on the first chart on a standardization we make it to 0 within a range of with a standard deviation of 1. Okay. On the other chart again it is normalized to 0 and it is with a range standard deviation of 1, but initially it has a different standard deviation and its mean value. Mean value initially it was of 10, in the later case it was 200, and on the redefined and distribution we get our value mean as 0 and standard deviation as 1. So far as normalized data is concerned, when it is quite skewed, okay, when it is very skewed, like the range on the first chart it's from 0 till there are maximum skewness is from 0 till around 5000, but the more holding are around more frequencies are around let it be around 500. But after normalizing the data we can scale down to 0 at maximum till 0.05 or 0.06. But on the first data you on the first chart you could easily see that the variation is too huge, where on the second one the variation is very less, though on the distribution may not be properly standardized, but at least by variation it is very less. What about normalization? We are now emphasizing after differentiating normalization and standardization. So, normalization is the process of reducing measurement to a neutral or standard scale. For example, two temperature reading, one is with 68 degrees Fahrenheit and the other one is 25 degrees centigrade. We cannot just say 68 is actually bigger than that of 25, because they are in different scale. We need to reduce the measurement to same scale. In that case through the normalization process we can avoid the Fahrenheit or the centigrade scale. It only converts to the number, and those numbers are possible to compare, okay, are actually comparable. Normalization is the process of changing the range of the data. So, that this has also changed the the range of the data. Data set containing two features, that age, income, where age ranges from like 0 to 100, while income ranges from 0 to 1 lakh and higher. Income is about 1000 times than that of the age. So, these two features are in very different ranges. When we do further analysis like multivariate linear regression models, we have to actually scale down, otherwise the implications of one variable might actually have higher loading on the final regression coefficient. When we do further analysis like as I already say multivariate regression, the attributed income will intrinsically influence the result more due to its larger value. but this does not necessarily mean it is more important as a predictor. So, that therefore, as a researcher I will strictly suggest that you start with normalizing your data, even if they are on the scale it is free from its unit of scale. Okay. So, like if it is with different scale, it should be also normalized. If it is is free from units or its scale, still it is suggested to go with certain normalization. So, methods of normalizations, we usually consider three important methods. One is min max normalization, second one is Z-score normalization, usually we call it as standardization, and the third one is called normalization by decimal scaling. Now, we have all those practical session at the end. I am now clarifying all the concept to you, and once you understand and set the tuning of these details, then I am sure you will go into the depth of this with the practical sessions at the end of this particular lecture. Starting with mean and max normalization. This is in fact a simple version or simple technique of data mining or data filtration or data simplifications. This is a simple normalization technique in which we feed the data in a predefined interval. Okay. So, generally the interval is defined with 0 and 1. So, we need to transform with this formula. This is the standard formula for the the mean max normalization. So, this one is basically what the variable minus minimum divided by maximum minus minimum into new maximum minus new minimum plus new minimum. So, usually even some of the researcher only follow this part, value minus minimum divided by its mode value. They can take this v minus mean, its mode its the value divided by x maximum maximum max minus x minimum. So, only this part researcher also use to get the value normalize, but it is nowadays suggested to go for new max minus new mean plus new minimum. So, we will experiment and show it to you with the help of data and with the help of Stata. Now, as per the example of age and monthly income, on the first example, in the mean in the age column, minimum mean value is equal to 24 and maximum value is 47, that you can easily see. This one is the maximum value and this is the minimum value. And second one related to the income, we have maximum is 10,000 and the minimum is of 5,000. Okay. So, after getting these two value, we can normalize the data with the help of this formula. Okay. So, so here this is going to give us the new maximum value and new minimum value, and with that new maximum value, here again just with the first formula we can get the new maximum and new minimum value. Here on the age scale, I think this is 0 and 1, 0 and 1, here also 0 and 1. All right. So, the new maximum and minimum value can be actually can be derived based on the formula we have just discussed. Now, coming to the Z-score normalization or standardization. The values of attribute A are normalized based on the mean and standard deviation of A is for our the values. So, A values of V of A is normalized to V prime by computing V prime. Here is the V minus mean of E divided by standard deviation. A is in fact the value that is given. So, here as per as we have cited one example for Z-score normalization is also called standard normal distribution or called standardization. So, you might be confused about standardized coefficient and non-standardized coefficient. We will also discuss during our regression analysis, during our multivariate analysis. Standardized beta, non-standardized beta, what is all about. If you do not standardize your coefficient, if you simply run your regression, that is called simply unstandardized regression coefficient. Once you have standardized it and you have taken regression out of it, that is called standardized beta. Anyway, I will clarify those things later. The mean and standard deviation of the values, the attribute income are rupees 54,000 and 16,000 respectively. So, that is the mean and standard deviation. With Z score, we can just put this value. Okay. With Z score normalization at value of 73 1,600 for income is transferred to transferred to 73 1,600 minus 5,400 divided by 16,000. 16,000 is our standard deviation. And okay, so since the value is of the V value is this, so we have put the value here and accordingly we calculate it is standardized to 1.225. So, the third approach we will be following is our normalize by moving the decimal point of values of attribute A. So, the decimal point we can use it a values V of A is normalized to V prime by computing the value divided by 10 to the power j. Okay. So, j the smallest integer such that maximum or the mode value of that V prime or less than 1 would be considered. For example, the recorded values of A range from minus 789 to 990. Okay. That is the range is given. The maximum absolute values of A is 990. So, the maximum value of course will be 990. To normalize plus E by decimal scaling, as we just say, we divide each value by 10,000. Okay. So, since it is 10 to the power 3 times it is of to the power 3. So, j equal to 3. As a result, the normalized value of A range from 0.789 to 0.99. So, instead of that, we have actually got the, since we have divided by 1,000, not 10,000, 1,000. So, so we have normalized the scale from 0.7 to 0.99. Okay. So, so basically it depends upon how you have normalized to the decimal scaling. I think if you remember, I have discussed about the weight of the variable in NFHS. We divided the weight variable to and scale down to a normal range, isn't it? So, the weight in NSS is different than that of NFHS, and it has to be in a ratio scale rather than an absolute number. So, that we have discussed. Now, I am discussing about normalization of database, how we can go for normalizing the database. Normalization of database is the process of organizing data to minimize redundancy. The aim of database normalization is to decompose relations with anomalies in order to produce smaller, well structured relations. It usually involves dividing large tables into smaller and less redundant tables and defining a relationship between them. The objective is to isolate data so that additions, deletions and modifications of field can be made in just one table and then propagated through the rest of the database via the defined relationship. So, this is the meaning of normalization. So, there are different normalization labels, like there are few rules of database normalization. First rule, first normalization form, second normalization form, third normalization form, and fourth normalization form. The third normal form is considered the highest level necessary for most applications. We are going to discuss now. In the first normal form, we will eliminate repeating groups in individual tables. Any repeating groups are entered in individual tables, we will avoid those or eliminate those. Create a separate table for each set of related data and identify each set of related data with a primary key. With that, we can avoid the repeated entries. So, this is basically the first form. And we can create separate tables for each set of related data and accordingly identify which are actually repeated groups. On the second normal form, we will create separate tables for sets of values that apply to multiple records, and we will relate these tables with a unique key. Okay. So, with a unique key we can separate it out, and records should not depend on anything other than table's primary key. Okay. If anything that is entered, I think we need to separate it out. All right. On the third form which we said that it is the most useful form, we need to eliminate fields that do not depend on the keys. If beyond the keys some fields are not do not depend on the keys, I think we need to eliminate those fields. Third normal form prohibits transitive dependencies. A transitive dependency exists when any attribute in a table dependent of any other non-key attribute in that table. Okay, if any other non-key attribute in that table if it is dependent on that, okay, that's basically called transitive dependency, and that form actually in fact prohibit those dependencies, because there might be collinearity issues in the data set. Okay. So, collinearity issues should be also avoided, basically the linear form of collinearity. Then other normal forms are like this is also called fourth form, also called Boyce chord normal form BCNF, and fifth normal form do exist but are rarely considered. Disregarding these rules may result in less than perfect database design, but should not affect functionality. Okay. So, examples are there, we will experiment with this also here. Examples of normalization table, like in the on normalized data, how it looks like. You can just have a look, class 1, class 2, class 3, and they are by student ID, their name of the advisor, and their room number, these are given. So, first normal form with no repeating groups, it is visible here. So, like student details, advisor details, we are taking this together instead of separately, and then we can have a comparison. All right. Then coming to the second normal form, we will eliminate the redundant data. Once we redundant the data, those redundant entries which you have just seen, once we drop those, we are left with very specific need. Okay, and those are in fact required for the analysis. Finally, we are left with our final form of the data, and since we have eliminated the redundant data. On the third normal form which we have been discussing, basically eliminate data not dependent on keys. Okay, so those are not dependent on keys should also be avoided. All right, like here we have given student information and faculty information. I think here we have shown only data for advisor, advisor room, class 1, class 2, class 3, but we have some non dependent keys as well in this data, that has also been avoided. What is essential in this form is important. Aim of database normalization, what are the important objectives? Basically to arrange data into logical forms, logical groups, such that each group describes a small part of the whole analysis, and minimize the amount of duplicated data stored in database, building a database in which you can access and manipulate the data quickly and efficiently without compromising the integrity of the data storage. So, we said that first form, second form and the third form we have eliminated the repeated and on redundant or non-dependent keys. Okay. Then organizing the data in such that when you modify it, you make changes only in one place. Now we will be referring to our practical and supplementary data, and based on that we can able to clarify all those things. I am now going to experiment with this and then we will review. Okay. We will review once again with these approaches. 4 especially we are going to guide you: min max, z-score, decimal scaling and log normalization. Log normalization we are not discussing much, we will discuss it later. So, now let us go to that and clarify. So, here it is on the screen. First we will use the data. So now the data is here, we have opened, and now we wanted to go with first approach, first aspect of our discussion. I can show you this as well. What is the first one? I can show you the min max strategy. What you will need to do, first you try to understand that medical expenditure. We are from the sample data set, we are trying to understand what is all about the medical expenditure in our data set. Then we will also analyze with its summary statistics like mean, standard deviation and details, and how it varies, mean maximum values as well, how it varies. But we are now concerned with the mean value and the maximum value, isn't it? So, from the data now you can easily see. Let me just a minute. I am just going through the data first. There are so many entries, but from the data you cannot understand. If there are so many lakhs of entries, it is very difficult to read. So, next command we will give here is to understand the summary statistics. So, it is here. So, SUM medical expenditure, that is the data we are referring. Out of all those variables, we are trying to explain the medical expenditure. As we all know that medical expenditure data is usually skewed, okay, is usually overestimated, whereas the income data is underestimated. So, when it is skewed, it is better to normalize it. So, here in the data, after having this command, we get the summary of medical expenditure in total. There are total of 38,720 observations, and out of that the mean value is of 842.8 and the standard deviation was of 3988, and the minimum is 0 and maximum is 5 lakhs, maximum is 5 lakhs. So, after when we know that we have such a huge variation, so it is suggested that you should go for checking it's generating a value, a variable will generate a mean total and the max total. Okay. So, next attempt is to go for the command isn mean total. Okay. So, here it is. So, we have generated the variable here, and now and similarly we will also generate, this is what is the minimum value of medical expenditure, and that is generated, and second one is n max total. So, that is the command n max total, we get the maximum of that variable, both we have got now. So, what we will do here, we will check finally get the what what is that, we will get finally the normalized data with this command. So, here it is. So, generate a medical total, here made total, made underscore total is our normalized data with min max strategy. So, basically what is this, the medical expenditure total data, that is the variable I have been showing here, minus the mean total divided by max total minus mean total in the denominator within bracket. So, mean total, max total, everything all those details we have already shown to you. Okay. So, and we have generated those variable, mean total value variable and max total we have already defined. Now, this is in fact our finalized normalized variable, that is made underscore total. Let us see how it differs from the original one. So, we are going to check the check the browse of this one. We will take this first, we will see this. This is how it looks like. Initially there were absolute values. Okay. Now, we have got it within a normalized scale with 0 and 1 value. Alright. So, let us close this and check next one. So, here let me just show it to you once again. This is what we have shown to you till this. Now, we are going to operate with the next strategy, that is next attempt is to normalize the data through standard normal approach or through the standardization approach. Here what we actually require? We require the variable, we require the mean values and the standard deviation. Okay. So, to get that, we have to generate again the mean values first, mean values variable, then its standard deviation of that variable, then we will compute the Z score, Z standardization. So, this is all presented systematically. Let us operate it, and I am just closing it here, it is here. Okay. So, next we are generating this is n mean max is equal to mean of within bracket, mean within bracket of that variable. So, the mean expenditure value is derived. Next one we are deriving the standard deviation. So, that is n standard deviation. We have taken the name as SD underscore expenditure is equal to SD within bracket, the command is SD within bracket medical underscore expenditure total. So, now with the enter we will get that variable also. Just a minute. You can also check in between in the variables window. All those are created one by one, mean total, max total, then normalized variable which we have created, medical underscore total, then mean now we are operating with the new approach, that is standardized, normalized and normal standardization technique, Z score standardization technique. So, next step is to generate that Z score, since we have already defined mean value and standard deviation. So, Z score is equal to Zen, Z score, generate now Zen is not required, generate Z score, Z underscore score, we have taken that name is equal to the actual value, that is the medical underscore expenditure variable minus the mean expenditure which we have already derived, divided by the standard deviation variable which we have derived. Now, this is going to give us the Z score value. We can browse and check that as well. BR that particular new variable, it is going to give us in a new window. Okay. So, with the enter we will get this. Yes. So, Z score we know that it varies from varies from -1 to 1. Okay. So, that is the reason where we have got minus entries as well. So, it is within the limit, now it has been standardized. Okay. So, we can also check it to summarize form, but it is not required, you guys can easily check it. Then what comes later, we need to just check once as per our operation. Next one is we are going to scale down the data with decimal scaling approach. Okay. So, in the NFHS 10 lakhs, I think, as I already told you, So, and then now we just for your sample example we have divided by 1000 here. Okay. So, here the first approach is to get the first generate a medical underscore decimal point divided the medical expenditure divided by 1000. Okay. So, once we enter it will scale down the data by 1000. Okay. You can also note the missing values is generated. Why missing values are generated? We are going to clarify all those details in our next lecture. So, these are also important in our research. Then you can check after generating the new variable with its decimal scaling, decimal normalizing. Now you can check in the browsing window. So, br on medical underscore decimal the variable which you have created, now just enter. It is now divided by basically the data divided by 1000. Alright, so now everything is converted to a decimal range. So, next one I think we have also talked about in our data in our table is what so far we have done. We have actually done all those details. Z score normalization we have also done. Now we have clarified these. Okay, so you have to check between the lines, like these commands we have also given for all of you for your learning, for your practice. Ultimately this matters. Okay, and this is in fact the formula, and we have applied this. This is the one we have operated just now. Last one is just to go get a logarithmic transformation. Okay, log transformation of the variable. So, in that case simply you generate with a variable name, any variable name you can give, but better to take the name with log medical expenditure is equal to log of within bracket of that medical. I am just going to deal with that again, though I said I will not do it, but it is possible, we can easily do it with the same variable. So, we have generated that variable here gen log underscore medical total is equal to log of this aspect. So, that you can also check in our browse window, and once we enter this variable will be generated. Just have a look. This is log medical total has been generated. Okay, now we can check that in a browsing window. Okay, so it is here in your screen. It will give you in a logarithmic transformation form. Basically here this is the last column is your logarithmic transformation. We have browsed all the scales together now for the better comparison, for better learning. Now, which one should be used? This may be a better call for the research. Now, I can guide you that depending upon the data how you are taking it, like in the logarithm transformation as per the last attempt, we have transfer the data in with the log value, but if there are more entries are in 0 or in negative or even 1, in that case if you take log log 0 is not defined. Okay, and if you take even 1 entries, they are around 1 point something expenditure is given, your log value will be near about 0. Okay, so in the entries on your data more of 0 will be getting. So, that is why log transformation has to be applied carefully. Now, another one is called with decimal scaling, decimal normalization. In that case it is of course reduce the volume of the data to a scale to a range, but it is not exactly normalize the skewness of the data. But other two like Z score is used, and the max min strategy or min max strategy for normalization is important. Now, the original data is visible is placed on the first column, other 4 approaches are displayed here for your reference, which one is actually used. For first two, that is minimum maximum could be used, or Z score normalization is also suggested to use. Okay. So, in most practice we use the min max strategy. All right. So, this is all our guidance for your better understanding. I hope you must have enjoyed with these operations, and I suggest that you should operate it, and you will learn lots of things out of it, and you can apply for, like, you can also track like some approaches, develop some approaches to have what is called index formation through the normalization scaling. All right. So, anyway, those details I will guide you later. So, with this information, I think it is time to close. If you have any difficulties and doubts, do not hesitate and raise this in your live lecture or in your chat box. Thank you.